Hey everybody, this is Larry, this is Miko McQ3 of the weekly contest 491, minimum bitwise or from grid. Hit the like button, hit the subscribe button, hit all the buttons, leave a comment, whatever. Let me know what you think about this problem. So I think this is kind of interesting, but I think for this problems like this, and I feel like recently there have been many similar problems. So I think this is, for me, not super tricky. But I think the problem that I would say, if this problem was tricky for you, is that that while the ideas are the same, I think the thing with these bitwise numbers problems is that it's all about the idea, right? And if you've been learning or if you've been learning via memorization, either intentionally or not, by just memorizing patterns and all these things, it's possible that you miss some of the ideas, or at least you don't learn in a way such that you're able to kind of come up with new solutions or whatever, new to use solutions or whatever. And as a result, it becomes really hard. But the core idea behind these bitwise problems often is greedy. And what I mean by that is, what I mean by greedy is just that you're trying to optimize it in a way. Okay, let me step back a second. The core idea behind bitwise operators is that they do the bits, the numbers and the bits, or the digits and the bits and the digits, whatever. They don't affect each other, right? What I mean by that is, let's say you have like two numbers, and I'm just gonna write them in binary, and that's not the push. Two binary numbers, right? Whatever. You just kind of always kind of greedy on the most. It depends on the problem, obviously. Still, it's not always the case. But if you're trying to maximize or minimize, it's always going to matter. It's greedy in the sense that you always want to optimize for the most significant bit first, right? And what I mean by that is because, well, it's obvious, right? Because you could have, if you have and you have it doesn't really matter what the rest of the numbers are, if because this number, you can compare the rest of the number by just this number. So you're always going to be greedy in that sense of caring for the first number, right? And I've seen somewhere that, at least in my Discord, people call this, or they look at the code and it's way similar to binary search. There are a couple of ways to write binary search, right? But there's one variation of binary search where you look at the first bit at a time. And in that sense, if you just look at the code without the proper understanding, you may call this binary search. And not to say there isn't a binary search answer, but visualization is not code, and code is not visualization. I think sometimes people go, okay, well, if it's this, then the code looks like this, and then also if the code looks like this, then this is an X algorithm, right? And it's an easy mistake to make when you I wouldn't say mistake. Sorry, my apologies. But it's an easy shortcut to take, but you might not be aware that it's a shortcut, and sometimes it happens. And we look at the code, and we'll go over the code in detail, or at least in some detail later, my code anyway, and it looks like binary search, but it is not. What I'm doing is that I'm just looking at it one bit at a time. I'm looking at it, okay, well, if I'm comparing these two numbers, then I know that this number is good, right? And then what I'm doing is that, well, now I'm looking at the next number, right? Is it a 1 or a 0? Right? If there's no ones, then then it's a 0. So that's basically the entire structure of the problem. That's what I'm trying to do. So all I've been explaining so far, honestly, is not related to this problem per se, but it's just a general idea for these bitwise problems. Right? It could be bitwise OR, it could be bitwise AND, it could be bitwise XOR, right? It's bits at a time, and we are trying to minimize and maximize these things. And of course, for you do handle OR, AND, and XOR differently because it just has different implications. We won't go into all kind of details with that, for this problem, but we'll go with respect to OR. Well, so in this problem, we have OR, and we're trying to do minimization, right? What does that mean? Well, that means that there's only 3 cases or 4, depending how you want to do the loss of generality, right? You have to do, and do, right? Yeah. So you have these things, and you have an OR function, right? And you're trying to minimize. So then when we're trying to minimize, then the only question is, can this happen? If this cannot happen, then you leave with one of these two, which leaves you with a 1 in the digits, right? And of course, as we said, because we're trying to minimize, we're trying to just see if it is possible to get a 0. And for this problem, what does that mean? That means that, okay, now you have a grid of numbers, right? And you're trying to pick a number from each row. Okay, so then now we start with the most significant bit, right? The first bit. If we can we create a 0 from the most significant bit? And that's all I'm doing. I go through every number and I go, okay, is there at least one number that I can pick where, you know, the 0 can happen? Is there, and then if I can pick one number from each of these, well, at least one, right? It doesn't have to be just one, but if it is possible, then we can have a 0. If not, then the prefix is a 1, because it doesn't matter what anything is, you know, you just have a 1. You're gonna have a 1 anyway, right? Okay, so that's 1 digit. So then now the question is, how do you continue on, right? So let's say we have a prefix of 1. Actually, yeah, let's say we have a prefix of 1. What does that mean, right? And then now we're trying to figure out the second digit of it, 0 or 1. Well, then now we look at all these numbers, and because the prefix is 1, we know that the prefix just allow us to set the filters, if you will. And maybe you could actually like actively remove them from the list, actually, but then you have to go back and I don't know. But there's an active filter, right? Which is that now, for every of these numbers that you're comparing, you actually, I mean, we're looking at the second digit, but we're also looking at the first digit, right? And prefix before that in the future. And what this is saying, because this is a 1, means that the first digit can be a 0 or 1. Because it still will get the same answer if it's 0 or 1. So that's basically the idea. And then now the question is, okay, for all these numbers that are inside this, which is basically every number, because every number can be either 0 or it has to be 0 or 1. So for every number, so for every number we just ask ourselves, can you find, for all these numbers, can you find a thing on any number for each row? Can you find a number that satisfies this constraint of the first digit being anything and the second digit being a 0? So if you can find one for all these things, then it's good. And let's just say that you can, right? Then now you move on, and then now for the next number you have the prefix of 1 and 0. And then you try to find out 0 and 1. Well, now it's a little bit different, right? Because for the first digit, remember that could be 0 and 1. But for the second digit, it has to be a 0, right? Because if we find a number with a prefix that's a 1, then this changes the answer. So we have to filter those out. And then now, given that these sets of constraints, is there a way, given these two constraints, is there one where the third digit is 0, and then you just go through all of them? And that's kind of the idea behind this problem. And it just comes up to implementation. And I know that I said this in terms of like constraints and filters and stuff like that. And this part probably to some degree tests your understanding of bitwise operations. So you have to be I wouldn't say necessarily fluent, but at least be able to come up with the thing, right? I mean, it is easy to kind of look at bitwise operations and be like, oh, you probably just memorized it, you know. But if you kind of play around with it, if you work hard at it, you know, you can come up with it, right? It's not that hard, and I'll show you how I do it. But basically, yeah, this loop is what I said that looks like a binary search. Is just basically what I said, right? So one digit at a time, and we start at, you know, current is equal to 0. Right? With one digit at a time, if it's not possible to get a 0, then we have a 1 in that digit, and then so forth. And that's just, like I said, looks like a binary search, but now that you have an understanding and visualization, you understand that that is just actually greedy and trying to pick off the bits, right? And the one distinction that it may come up more relevantly is that if this is not a binary number, I mean, obviously, with bitwise operations, it has to be a binary number. But let's say there's a variation where it's base 10, then this may be a for loop, and then as a result, then you wouldn't call that like a decernary search, right? I don't know if decimary search, whatever, right? But you get the idea. If it's base 3, you wouldn't call it a ternary search. The ternary search is also different, but you get the idea, right? Anyway, yeah. So the possible, and this is very tight code, and this is what I explained already. So hopefully I don't have to explain at least the idea. We'll explain the code, but you don't have to explain the idea. But yeah, so for each row, we try to find a number in which this is true, and if we found it's true, then yeah. And if we don't find any number for that row, then this is not possible for this to have a 0, given the constraint where the prefix is. I say less than, but it's not quite that, right? It's not less than in the number sense. It's less than in the bitwise OR sense, right? And then you have this thing, which I will explain, right? So this part, I hope I don't have to explain too much. It just means that the ith, or the index ith digit is 0. Right, that's basically it. And then this part is a little bit confusing to look at. And just to be clear, like it's not something I memorized. I come up with. I just kind of worked out what it needs to be. And in fact, if you watch the live portion, I was like, is this index or index plus 1? It actually turns out it shouldn't matter. Actually, for fun, let me see if that actually. Am I lying? Does it actually matter? Let's see. Yeah, so it doesn't matter, but it doesn't matter not because it's correct. It just doesn't matter because of, we'll show you in a sec or afterwards, right? But this is actually more precise. The idea here is that, okay, let's say we have some prefix and then we have another number, right? And it could be, and then the idea here is that, okay, the shift just means that we get rid of the suffix, right? So then if we shift by that much, that means that what we're keeping is just the prefix. So in this case, we shift by here, and then now we just get rid of the prefix. And that's the entire part about the shifting. And we shifted both on this and on the current, because current, we only care about the prefix for this problem. And then we also shift for the number that we're caring about, because that's the basis of comparison. And then the idea here, and there are probably multiple ways of doing this, by the way. You can also, for example, you can XOR this, because now we're just trying to make sure that, no, XOR wouldn't work actually, I lied. But there are other ways to do it, possibly, I don't know. But the way that I came up is that, remember that, so we have this, these two are the same, so that's very basic. But let's say that we have this is still true, right? We still want this to be true because we want, this is the number, this is the current thing, right? Because we know that, and current, it's really like a prefix constraint, if you will, right? Because this 0 means that this 0 does not, still can lead to 1 in the answer, right? So that we don't want to filter this out. And then I worked out, okay, well, honestly, if you can look, I mean, this looks a little bit confusing if you look at it from all the bits at the same time, but you can just create a truth table, right? So basically, we want to create a truth table where the number and the current, or the constraint, I just like constraint, right? If the number is 0 and this is 0, we want this to be true, right? Or 1. No. Yeah, we want this to be true. If this is 0, this is a 1, we want this to also be true, because that's fine. If this is a 1 and this is a 0, we actually want this to be false. And then now we have, if this is a 1 and this is a 1, then this is true, right? And of course, you can, write it in more ways, but this is the way. And if you look at this and then you just notice that this, so you can actually, interestingly, you can just, I mean, if you really want to, I wrote it this way, like I said, but, well, you can't really write it this way just because, just because I think complexity-wise or timing-wise is a little bit too slow. Because because one thing about this is that it's a bitwise operation, it is fast, but you can, in theory, even write like if number and not constraint, then return false, right, or something like this. So you can like kind of write an if statement this way, converting it to kind of what I have here. I mean, and you could obviously, you know, just show this, right? Like number to constraints equals to number or whatever, or constraint, sorry. You could and I kind of, and this is very long, so let's just write f is equal to formula is equal to this, right? And f, you can see that, you know, this is going to be 0. Yeah, this is 1. This is 1. This is also 1, right? And as a result, you know, you can, this matches what we want, right? Because this is the only case where that's not the case. Anyway, my point is still just, you know, you have to play around with it, and once you do actually figure it out and do it a few times, you come up with ways to just write these kind of ideas and express them in a consistent way. I would also say that, like I said, there are probably multiple ways to write this particular part, and I don't doubt it. It's just that the way that the reason why I wrote this is not because it's the only way that's correct. It's just that's how I probably written it a lot of other times. I've done similar problems, and that's what I came up with. But yeah, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and yeah. Okay, well, I mean, without this stuff, you can fit everything on one page. But yeah, yeah. So what's the complexity, right? Well, this is all B, where B is the number of bits, 20, and this is just going to be linear, right? We look at every element once, so it's B times N, and that's it. Yeah. Thanks for watching, and you could. This is a longer explanation, so we appreciate it, especially if you're up to here. Hit the like button and or subscribe, leave a comment about something, and yeah, you can watch me now. Solve it live in the contest now. All right. Minimum bitwise OR from grid. Okay, so we have an R and C grid. One integer from each row of the grid. Return to the minimum possible bitwise OR. We have a lot of possible rows, but number of items is true. How would I do it? Hmm. 10 to the 5th. What's 10 to the 5th? 10 to the 5th is 2 to the 20. 20 bits. 20 bit times n seems a little high though. So, How would I do it? Bitwise OR. You kind of want it greedy, right? So, I mean, with these things, you just kind of want it greedy, but not in like a normal greedy way, but you want it like a bit at a time, right? So then maybe we write, what's it? So B is equal to 20. 2 to the 20 is a million. That's good enough, right? Okay. And then we just want to see if it's possible to do, yeah, like for I, if possible I, then something like this, or current is equal to 0. If it is possible for it to be a 0, then nothing happens. And if it's not possible, then current to do 1, right? Yeah, okay, something like this. And then we just return current. So index say, and then what we want to write is, what is this function, right? So is it possible to get a number, this is wrong, I don't know why I wrote it this way, number from every row to get 0 where the prefix is less than current, something like this. I mean, I'm probably not that precise, but I'm trying to write code and not this for now. Maybe an explanation will clear it up. But okay, so then now, because then now this would be B, which is 20 times R times C, which should be good enough. Okay. Oops. So then now, all right, found is equal to true, meaning that, okay, so if grid of row column, because basically it has to, what am I saying, right? It has to have the prefix, it has to have, so for every bit in the current, if it has a 1, this can be anything, but if this has a 0, so this does not add to the current. That's what we want to say. So how do I write that precisely? So maybe something like this. I don't know if I'm off by 1 here. That's the part that I'm like hesitating on. So something like this. If this is not equal to, or if this is equal to current to the index, right? Because what that means is, and maybe we could do C lookup. Is it index or index plus 1 or minus 1? I have to. That's gonna mess me up. Okay, so if this is the case, it means that this is a valid thing, and then grid of is greater than 0, something like this. If this is actually equal to 0, whoops, then found is equal to true. I don't know why I had it this way. Oops. So if found, then we are good. If not found, then we just return false. It's not possible and return true. This may be index plus 1. Okay, let's think, right? So let's say index is, so 0, we check the last bit, then this shifts 0, which I guess it actually doesn't matter because current would not have anything on that bit, but it's still not precise. I think this is actually index plus 1. I think it actually like would work out in either case because we don't set it yet, but it is definitely not precise. Okay. Invalid syntax. Oh, I don't know. It's just a long word, so if the okay, maybe this is a little better. Okay. 357. I'm going to YOLO submit. I think this is right, but it could be off by 1 and something silly. I think okay, good. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem, this contest, everything in between. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.